Good morning, everyone, or good afternoon to everyone, depending upon where you're joining us from. We still have a couple people that are logging in, so we're just going to give them a minute or two to get settled in, and then we'll get underway. In the meantime, I just wanted to go over a couple items. I'm Moira, the Vice President of Marketing and Communications at Watson, and I'd like to thank you all for joining us for today's webinar on the magic of spray drying. Today's webinar is being presented by Watson, one of the highest quality manufacturers of value-added ingredients formulated to enhance human health and nutrition, including a line of industry standard and custom spray-dried products. Before I introduce our speaker, I'd like to just cover a couple housekeeping topics. We encourage you all to share your comments and your questions. So please look for the Q&A chat box on your screen. If you have a question, just type it in there and I'll hold it for discussion at the end of the event. If we run out of time, we're going to follow up with emails to answer any additional emails that we receive. Today's webinar is being recorded. We'll be able to share a link via email tomorrow, and we invite you to revisit the content yourself as well as share it with your colleagues. We have a comprehensive 12-page guide to spray drying, which will be available for download in the next few days, and we're going to be emailing you a link to download our spray drying guide as well. If you're planning to attend Supply Side West next week, you can stop by our booth and pick up a printed guide. I encourage you to ask for a printed copy. It makes a very handy desk reference. Today's presenter is Amit Sinha. He's one of the industry's leading experts in spray drying. I've had the pleasure of collaborating with Amit over the past 2.5 years at Watson, and he's currently our process innovation engineer. Before I hand it over to Amit, we just wanted to start our first poll to kind of gauge how people are as far as their familiarity with spray drying. It'll help us to kind of fine tune our content. Okay, just give it another second or so. Okay, I close that and share results. It looks like about 70% of you have some knowledge of spray drying, 21% say that you're a novice, 6% are experts, and 4% buy some spray-dried ingredients now. So, Amit, at this point, I'll hand the presentation over to you.
Hi, everyone. Welcome to the spray drying webinar. We're going to start off by defining what spray drying is. Spray drying is a micro-encapsulation method. Simply put, you can take a liquid slurry and convert it to a powder. Many of you know of fluid bed encapsulation. So what makes fluid bed encapsulation different from spray drying? Think of an M&M and its perfect coating. That's a great example of a fluid bed encapsulation technique. Spray drying, on the other hand, is represented in this example of the cookie, where the chocolate chips are the active that you're trying to protect. As you can see, some of the chocolate chips are exposed and some are embedded in the cookie. That is how spray drying differs from fluid bed encapsulation. The second image here describes the basic spray drying process. We'll go into much more detail as the webinar goes on about the process, but I wanted to kind of give you an overview of the process here. What happens in the process is you're introducing a feed along with hot air concurrently into this drying chamber, where due to the temperature differential, your slurry dries, the fines are separated through the cyclone, and then you're able to collect your product. Before we move further into the spray drying process technique, let's discuss why you should spray dry. Perhaps you have an ingredient in your product that is oxidizing too quickly, or maybe you simply just want to use an ingredient that gives an off taste to your product. Or maybe you just need to find a way to have controlled release of your ingredient. Sometimes we're in a situation where it's more economical to ship powder than liquid. So in all of these challenges, spray drying can help you. The image on this slide is an example of a pilot spray dryer. This is known as the mobile miner. It has the same components as we discussed earlier. You have a nozzle, you have a chamber. This bottom part, a conical area, is known as a bustle. The dried powder from the chamber goes through this bustle, goes to the cyclone, and you're able to collect the product in this glass bottle. More detail on the spray drying techniques will come up. This pilot unit can dry at 0.5 to 6 kilos per hour, and that's your water evaporative capacity. Those are theoretical numbers that most manufacturers supply, but depending on your formula, those numbers vary, and hence there's a range. Now that we've talked about why you should spray dry, let's discuss what can be spray dried. Watson can help you with many ingredients that can be spray dried. Some of our most common ingredients that we spray dry are vitamins and minerals. But did you know you could also spray dry juices, essential oils such as borage oil, and nutritional oils like MCT and coconut? Each of these ingredients can show up in many different applications. For example, gummies are a fantastic way to get vitamins today, but these vitamins must withstand the heat process. So spray drying encapsulation can help you with that. With a growing need for clean label items, juices are showing up in many nutritional bars. To get that juice and its nutrient value into that nutrition bar, spray drying can be one of those tools to help you. And finally, supplements are constantly using spray-dried ingredients such as vitamins and MCT. Next, we'll talk in detail about the spray dryer itself. In this image, you can see another pilot dryer. This pilot dryer can dry at 5 to 10 kilos an hour, and that's the water evaporative capacity. This dryer looks different from the mobile miner, and that's due to the surface area that's projected in this dryer. You again have a chamber here. You have a nozzle at the top. You're pumping your slurry from the bottom here to the top of the nozzle. It's co-current with the airflow going down. The temperature differential allows for the air to dry the product, and the air carries your product through the cyclone into a product container. The dryer can come with a bustle that is either conical or a flat bottom, and each one has its own benefit. Flat bottoms are typically used for those products that have a high sugar content. Your feed slurry are two important areas to concentrate on when drying, as that is your matrix that you're trying to hold together and dry. So it's important to know what your carrier is, what your active is, and what other components you need to successfully spray dry. And the atomizer is a huge component of the spray drying process. It comes in a nozzle as well as a wheel choice, which we'll discuss a little bit more later. Pump choice also makes an impact as your slurry is going to be fed through this pump. So do you want some of that shear forces to increase your temperature? That may cause some thinning of your product and affect your viscosity. Other steps that could be part of the spray drying process are batch pasteurization and homogenization. Both are important for your product, as the batch pasteurization is a great micro kill step, and the homogenizer is great to combine your two phases together to have one uniform particle come out. Obviously, you don't want to have just the oil come out or coat the dryer and then not have a successful formula. The drying is critical, and that's based on your temperature differential. And then the powder separation step is also where you're collecting your product. Packaging is another area that can influence how stable your product is. Now we'll talk about the impact of the nozzle choice. As I mentioned earlier, you have two choices, the nozzle and the atomizer. That nozzle can also be further broken down into a two-fluid nozzle or a pressure nozzle. The rotary atomizer is similar to, think about a merry-go-round, where the faster you spin, the more particles come off. That's the concept. The difference in the three atomizer choices are seen here. You can see a huge range of particle size difference between the rotary and the two-fluid nozzle and the pressure nozzle. Depending on your particle size specs, you may want to consider that particular nozzle. Another area of concern is as you're drying, and depending on how that particle is coming out, if it's coming out too fast at that tip, you may have a hollow particle and may not be as uniformly coated as it hits the rest of the dryer and falls through the dryer to the cycle. These are all considerations when drying a product successfully. We talked about the homogenizer and its impact in the spray drying process. That impacts your emulsions. For example, if you're looking to have a better stable product, what is it that you can do? One of the best areas to control is your emulsion. What should you do to control it? You should pick an emulsifier that has the HLB value, the hydrophilic lipophilic balance value that works for your system. If you have oil-water emulsion, you probably want to look at an HLB value that will work for that versus a water and oil emulsion. If you're looking to make multiple coatings, perhaps you can do a multi-layer emulsion. And how that works is you have an oil-water-oil phase or a water-oil-water phase. And again, you will have two separate types of emulsifiers or more to get that value that works for your system. Another thing that influences your emulsion is your particle size spec. So if you chose a particular nozzle, for example, you picked the rotary wheel, you would see that the particle size distribution is much broader here than when it is under a 2-fluid nozzle or a pressure nozzle. So their differences can impact your final particle spec significantly. Other common considerations when developing a product for spray drying is your regulatory. Does your product need to be allergen-free? Does it need to be non-GMO, organic? Some of these other criteria are just as important as when you're developing your formula, as you may be limited by the ingredient choice that you have. The active amount that's necessary, that's a consideration that should be part of your formula development. What percentage are you trying to coat? All of these criteria can impact your final formula.
Okay, I'm going to put together our second poll here. And so our next question is, do you currently use spray-dried ingredients? We'll just give people a second here. Votes are coming in. And I'm going to close the poll. And it looks like 62% of you do, which is fantastic. All right. Amit, back to you.
Now we'll talk about the formulations. Some basic considerations in a spray drying formula. Typically, Watson works with water-soluble ingredients. Organic solvents are typically not favored for spray drying production, as the equipment needs to be designed for that solvent. If your system is water-based, now you've got other components that are necessary to make it a successful spray dried product. When we talk about an active, we're talking about what needs to be encapsulated, what medium is it captured in, which would be the carrier, and the flow agent, which helps in the processing of your product. An example of this is, say you have an MCT oil that needs to be encapsulated in a starch matrix, and you've got a processing aid of silica. And all of this is dissolved in water and in a slurry and possibly homogenized and then spray dried to result in a beautiful white product seen here. What is meant by active? Well, we discussed the active is what you're trying to encapsulate. So one of the considerations is your active water soluble or oil soluble? Because that will lead to a different processing method. Does your active have a low flash point? That number usually you can get from the SDS, and that's important to know, especially if it's going onto a spray dryer, so that you're able to successfully dry it and not endanger your operator. Has this active been successfully spray dried before? If it's something new, then there should be some development work that will be needed. How pure is your active to determine how much of that active you actually use in your formula? What percent load is it commonly found at? If you're trying to achieve 90% coating, and typically the industry standard is 50, there may be some hard work ahead for you. And then finally, based on your answers to some of these questions, you may choose that spray drying is the right process, or you may not. The carrier is another huge component of the formula. There's lots of carrier choices out there. Starches are most common. You have a host range of starches. You've got cornstarch, modified food starch, and tapioca and potato, and so on. Maltodextrins are typically the most economical. You can choose it based on its DE or dextrose equivalent. A dextrose equivalent of over 20 indicates you're heading into the corn syrup solids range. The higher the DE, typically the more sweetness impact you're going to have. And of course, the higher the sweetness, then you're going to have lower heat resistance, and you may have some browning effect in the dryer, which you want to avoid. Gums are a great carrier as well. Not only do they serve as an encapsulation carrier, but they also serve as an emulsifier. And cyclodextrins are becoming common as they're offered in alpha, beta, and gamma, and each version is basically a cup-like structure with a hydrophilic and a hydrophobic component, which allows you to work with fat-soluble vitamins and minerals. And then there are other carriers, such as dry yeast, that can also be used for spray drying. Flow agent is another component of the spray drying process. I've described it as a processing aid. Typically, we use silica, and it helps avoid the caking that happens in the dryer. If you tend to run a product for 10 straight hours on the dryer, you're going to have quite a bit of buildup. To avoid some of that buildup, we use the flow agent to help knock some of that product down. Oftentimes, you choose the flow agent based on your regulatory requirement. Sometimes silica will not work, and you may need to look at TCP, or tricalcium phosphate, as an alternative. There are other newer alternatives, but remember, those aren't a one-to-one replacement, so you may need to consider your application before choosing those. And finally, the flow agent's purpose in spray drying, especially if it's added in the spray dryer, is to improve the processing. If you're looking for the flowability of your product to improve, it might be better to add it after it's spray dried and blend it. That way you have 2% that's uniformly present in your blended product. Water is another huge component of spray drying. Spray drying is essentially water removal. The more water you have, the longer it takes to dry, and the higher the cost to dry. So when someone asks you what is the percent solids, it's always good to know what that number is. If you have a product that is 25% solids, that means it's 75% water. There's going to be considerations. It'll pump really easily. It'll dry easily, but you're going to have a lot longer run, and efficiency may go down. On the other hand, if you have too little water, you have viscosity issues. You may not be able to pump your product through to the nozzle, and you may affect your particle size as well. So a key step in determining the success of your product is finding the balance of percent solids. Other ingredients that tend to show up in formulas include antioxidants and emulsifiers. You have a host of choices for antioxidants today. BHT and tocopherols are typically common ones, and emulsifiers are chosen based on their HLB values. Typically, monodiglycerides and gums and lecithins are mostly prevalent. But again, you need to look at your formula to determine which one works best for you. Now we'll go into some formulation examples. For example, if you have a need for a beta-carotene that's stable and can have a good shelf life and provide some sort of clarity to your product, your beverage, what do? First solution is come to Watson. We offer multiple types of beta clear that could help you. And we also can provide you the support to determine what solution works best for your product. For example, if you have a beta-carotene need, we'll determine what medium it needs to be solubilized in, at what temperature. If you go over a higher temperature than that's required, perhaps you're converting the isomer from cis to trans or trans to cis, which could have an impact on your clarity and your processing. We'll help you determine how much antioxidants do you need to help increase shelf life. And finally, if clarity is an issue, we need to look at particle size. Do you look at the particle size after it's dried, or of your raw materials as well, as particle size and color can be impacted together. And finally, perhaps to achieve the level of clarity that you need, you may need to add another unit of operation, such as fluid bed agglomeration or encapsulation or bead milling. So taking your project into consideration, some of these key questions might be answered before we proceed. Another example of a spray dried application is you have a requirement for a high oil load. For example, you want 60% of MCT oil. What should you do? Well, first I would look at what carrier options do you have. Ask your supplier, what's the maximum oil load that this carrier can hold? Some suppliers will tell you right away that our starch can only hold 30 to 40% oil and would recommend something else. Typically, when you're looking at a high oil load sample, you're probably wanting to use something like a potato starch or a tapioca starch. Though the drying process is a little more difficult, it does work. If you have no allergen restrictions, and most non-dairy creamers today have sodium caseinate, so you might be able to use that for binding. If not, you have pea protein as an option. If you are looking to prevent some of that coagulation that occurs when it's drying, you may want to use dipotassium phosphate. And of course, you want to add antioxidants to increase your shelf life. Since you have a high oil load challenge here, one of the key things to remember is to add a flow agent during processing, because that will help get that product off the chamber. As it cakes up, it'll be impossible to brush it down, and you will have yield losses. Another challenge you may be presented with is I need to use a vitamin E powder that will help impact my clarity in my beverage. The solution is ask Watson, which vitamin E can we supply you that would help you achieve that clarity? In this image, you can see 3 different versions. In the center, you can see the natural 15% spray-dried powder. You can see the impact the spray-dried application has. What's critical in answering this challenge is knowing the amount of active you're seeking, how much vitamin E should be in this product, what emulsifier should you use, as that will dictate how stable this emulsion is before it gets spray-dried. You have several choices out there, but only 1 or 2 will work to give you that clarity effect. What carrier should you use, and what flow agent? And the reason all of these are critical is because every ingredient impacts the clarity. So just tweaking your formula by 1 or 2% could make the difference between clear and not clear. And you can measure the turbidity via a turbidimeter and determine what NTU satisfies your criteria. So now that you have a great product, now you're running into the stability issue. What can you do? If your stability is tanking, well, do you redevelop the formula or do you look at other criteria? One of the first things I would recommend doing is doing an accelerated versus room temperature stability. I currently use the AOAC guidelines, which is 75% relative humidity and 40 C to determine my accelerated room study. Room temperature is, of course, your temperature of your room at 25 degrees Celsius plus whatever your time point is at that month, 1 month, 2 months, 3 months. Packaging is another area that can impact your stability. You have several options to improve stability, including choosing to heat seal, vacuum seal, or nitrogen flushing. You can also use a foil bag or a mylar bag. All of these are valid options to consider improving stability. But note, none of these will be inexpensive. They will add cost to your final spray drying formula. If you've done all of those things above, what else can you look at? And your stability is still tanking. Perhaps you should start at your raw materials. When was it brought in? How was it stored? When did it start degrading if you have that data? Did it come in with a low potency? Perhaps those will answer some of your stability issue questions. Perhaps now, after looking at all this, you decide, okay, I need to increase my overage in my formula. Well, maybe you add that extra 1 or 2% if it's not cost prohibitive. And finally, you may need to consider processing. Was the product dried at too high of a temperature? And maybe the spray dryer needs to be dialed down a little bit. So why should you choose spray drying? Well, there are multiple reasons. Cost, it frees up equipment. For example, if you look at this image here, you have an image of B12 that is blended into a product, and then you have an image of a B12 that is spray dried. You can see the uniformity in the second picture. If you're doing B12 1% on a fluid bed and you convert it to the spray dryer, now you've freed up your fluid bed, which is a batch process, and you're moving to a continuous process. Though you're switching products and making exactly the same thing, you're going to have two very distinctly different final products. So that's another consideration. It's not a simple switch. If you are switching equipment, you might want to also consider switching formulas. Sometimes, for example, in a B12 1% formula, you may need to add a buffer system such as citric acid or sodium citrate. Any formulation changes that are made must be made before they go to the spray dryer because it will not run the same.
Okay, it's time for our third and final poll. I'm going to put that up. All right. So I'll give people a second here. Talk about if they own a spray dryer, if they go to a contract manufacturer, or if they've never used spray dried ingredients before. And just 1 or 2 more seconds here. Okay, I'm going to close the poll. And it's pretty close between they own a spray dryer and they go to a contract manufacturer for spray drying.
Thank you, Maria.
Right. Yeah.
So the next topic we're going to talk about is what happens if you want to spray dry, but you don't have a spray dryer. First answer is come talk to Watson. Let us help you figure out what we can do to help you solve your spray drying needs. Second is ask your contract manufacturer that you're working with or try to locate one that can help you answer some of these questions we're going to discuss. It's important to know what capabilities your contract manufacturer has. Can they handle solvents if that's important to you? Or are they only water-based? Do they have a pilot unit? That might be impactful for you before you even get to the large spray dryer because you want to save some of your costs associated with scaling and failing. The pilot unit will give you a great representative sample. Usually if you're spray drying on the pilot unit, you're getting feasibility out of it. You won't be able to set specs and you won't be able to say this is where my particle size should be and this is where my moisture should be, but it'll give you a great indicator of what to expect. There's always significant improvements when you scale up. And the main reason for that improvement is because you have a larger surface area on a large production dryer. Plus, the larger the batch size on a production unit, the more representative of meeting your particle size specs and moisture specs that product would be. What is the minimum batch size for your dryer? That depends on your project and your need for the sample. If you choose to do feasibility, then the pilot unit might be the best option for you, and you might be sufficient with a 1 kilo sample. But if you need more to do stability, you may do 50 kilos or larger when you get to scale up. What type of atomization should you use? Those are good questions to ask your contract manufacturer. Sometimes they may only be able to tell you, I can only do a 2-fluid nozzle and I can only do a wheel. They may not be able to retrofit their dryers to go back and forth. Another good question to ask is, does that spray drying facility handle those type of products that you want spray dried? Oftentimes, the spray dryer is a spray dryer, but it can't run that product if you've never run the experience, if you don't have the experience to run it. A lot goes into the processing, the pre-processing before it gets to the dryer that could dictate the success. What is the lead time? Oftentimes, you need to schedule with your contract manufacturers well in advance. And do they have quality on site? How important is a quality product to you? And how is it monitored? And finally, documentation is key. You would like to know everything about your product, so transparency is extremely critical when developing your process. Other questions to consider include the kosher and halal status. How important is that for you? We mentioned earlier in the processing step that there could be homogenizing and pasteurization. Is that important for you? What type of pressures can they reach? If you do your pilot work at 7,000 psi and the scale up can only do 5,000 or 4,000 psi, now you're in a conundrum. So what should you do? What I would suggest you do is find a way to develop it so that you can homogenize twice. For example, if you're able to get a successfully homogenized product at 6,000 or 7,000 psi and your toller can only do it at 5, can you modify your process on the lab side and homogenize at 3,000 psi twice and see if that impacts your emulsion? Or perhaps you need to recirculate your emulsion for 45 minutes at 5,000 psi if that's what you can handle. So there are multiple ways to address that scenario. Is high shear mixing important to you? Again, that's another level of homogenization that can impact your final product. What is the pasteurization process for that company? Is it batch? Is it ultra high temperature? There's multiple ways to do pasteurization. If it's batch pasteurization, you're probably doing it at 155 degrees Fahrenheit for about 30 minutes. That's a good enough kill step. And then you might be able to continue further in your processing. Another key area to know is what equipment do they have? How do you make your oil phase, water phase? How many tanks do you have? Is everything got a steam jacket? Can the temperature be maintained throughout where you want? If you need a process to be where you have an oil phase separate and a water phase separate, can that be done? Can those temperatures be maintained? How is it going to be transferred? How much product loss are you going to have in that transfer time? Those are all impacts on your yield. What percent solids is a very key and important question to ask, because that also dictates the length of your runs as well as how quickly they're able to hit your specs. And finally, what type of dryer do they have? If you have a high sugar content product, a juice, for example, do you need a carrier in it? If there's no carrier, how is it going to dry? A flat bottom would be the best recommendation, but again, it's all dependent on your formula. If you're looking to enhance your product, perhaps they may have an agglomeration tool that can help you. There's a lot of dryers out there now that have a fluid bed that's integrated with the spray dryer, and you can directly agglomerate that particle to make it a little bit bigger. Again, that will add more cost to your spray drying process. And finally, micro requirements are something that you have to ask your toller about as well. We discussed how stability is impacted by packaging. So the next question I would have for them is, what type of packaging do they handle? Some tollers can only handle super sacks. Others can do only bag and boxes. Is that the scenario that you need? So you should always discuss every option and see what works for your product and your stability. If you come to watch them, we'll help you handle some of those issues. Some factors that can affect spray drying significantly. We talked a lot about the formula. If it's not formulated right, it will not dry. Oftentimes, the pilot sample will be your best indicator of success on the large scale. Ingredient choice. We talked about how the clarity is affected by your ingredient selection, for example, in vitamin E. What is that percent load of your active and what ingredients are you using? How are they impacting your final product? Selecting the wrong ingredient could lead to a failed formula. Order of addition can be critical. Sometimes adding an oil phase to a water phase in a particular order may make all the difference between a successful emulsion or one that's not. Atomization choice, we talked about the nozzles, how that can impact meeting your specs of particle size and moisture, and slurry temperature, viscosity, and pH. Slurry temperature is important as a factor because oftentimes you're going to have to thin out your sample, make it a little less viscous so that it can spray dry and pump. You're affecting viscosity significantly. Oftentimes, if you're having issues and you get some sort of like cotton candy powder in your dryer, you need to look at your pH. The pH may be the first indicator of an issue. So you need to look at any variable that you think could be contributing to your product failure. Some final thoughts. I would say that the most difficult part of the spray drying process is not the actual drying of the product, it's everything you do before and after. If you're able to successfully dry on a smaller unit, that's a great indicator of how it's going to behave on the large scale. If you have challenges on the large scale, it's a very costly challenge. I've seen oftentimes where the product has stopped drying because the cyclone has been plugged up. If you're doing any sort of reaction, you must make sure that you're able to control that reaction before it hits the dryer. I would say my biggest recommendation would be to work on your formula first before you decide to successfully manufacture it in production. At this point, we'll open it up for questions.
Okay, and just as a reminder, if you have a question you haven't asked yet, please use the Q&A chat box and submit your question. Amit, do you want to select a question?
Sure.
And also, as a reminder, we'll be sending emails out after the webinar if we don't get a chance to answer all the questions.
So one of the questions we had is, what moisture content is typical of a spray-dried material? That depends on your formula and the product you're trying to achieve. For example, if you have a requirement to dry vitamin A, you may start off at a moisture level of not more than 6% on the pilot scale. And then as you decide to use it in your final formula, you may drop it down to a moisture level of 3 to 4. Typically, it's up to your company or your contract manufacturer to decide what is the optimal range. They may come back with a recommendation saying, okay, we saw this as a problem product and it runs better if it is at 6 to 8% moisture. And if that can be added onto your spec, that would be great. Otherwise, you'd have to work with that company to decide how can you tune it, fine tune it a little bit further. Another question is, what temperature do you usually spray dry at? The spray drying temperature, again, is dependent on your facility's dryer. No two dryers run exactly the same. There's always a difference, not only in the construction of the material, but as well as the setup. So typically, you might find companies drying at an inlet and outlet temperature of 400 Fahrenheit and maybe 225. You need some sort of differential. I've seen dryers run at almost at 550 Fahrenheit. So it just depends on what you're trying to dry and how much of a challenge it is, as well as what's in your formula. If you have a lot of carrier and very little active, you might be able to dry it at a much lower temperature. The caveat to this is the higher the temperature, you might result with a product that has more browning in it. Another question I have is, are desktop small-scale spray dryers used to test products before upscaling? Yes, and there's various types of pilot units out there available. You can have desktop units that actually sit on your desk, so they're that small, as well as the ones that we showed in the illustration with the mobile miner and the next scale up, which was at 5 to 10 kilos an hour. And then the scale-up dryers usually end up going all the way up to 2,000 pounds an hour. So you have quite a range of dryers available. Typically, you don't want to start your development on a production scale-up dryer. It'll be very costly in terms of raw material and time. Oftentimes, if you're wanting a small batch of 200 pounds, it's probably going to cost you more for the cleaning than it is for running that product. So always try to scale accordingly. If your facility is able to have a small pilot unit, that would be the best place to start to see the feasibility of your product. If you start at 500 pounds and on a dryer and yield is not of consequence to you, then that might be another way to consider it. But again, might be paying more for cleaning than for actually drying.
While you're looking for maybe one more question, I think we have time for one more, but while you're doing that, I'll just say that this is our contact information. And if you have any additional questions or you'd like to connect directly with the Watson team, please contact us. And we'll be emailing all attendees links to the recording of this presentation as soon as it's available. And we'll also email you a link to our spray drying guide in the next couple days. And if you're attending Supply Side West, we really do hope that you'll stop by our booth and get a hard copy of the guide. Amit, did you have another question?
Yes. Another question that came up is, how is the flat bottom different from a conical bottom in terms of the mechanism? The main difference is how you're collecting the product. Now, with a cylindrical flat bottom, you have more surface area. So your product is able to collect along the edges of it a little bit differently, whereas with the conical, it drops pretty quickly down via the air into the cyclone. So how do you get that product? Oftentimes, there's a brush installed in that flat bottom that will sweep out that product, and it's set by your facility or your contract manufacturer, and it sweeps that product down so that you're able to collect most of it without there being any buildup. And I think it's helpful to use a flat bottom, especially when you have high sugar type items, juices particularly, because those tend to dry a little bit better, especially if you're not allowed to add a carrier to it.
Oh, okay. So if you've asked, I'm sorry, go ahead, Mehmet. You have another question?
Right, yes, and I'll answer this one last question is, does spray drying affect the nature and properties of the product? It can. It depends on what you're trying to set out to achieve. For example, if you're looking to maintain the nutrients of, say, something like spinach, obviously you need to make sure that the consideration of high heat under spray drying, we just talked about how the spray drying temperature could be at 400 degrees Fahrenheit. And with that difference between 400 and 200 at outlet, now you have a 200-degree difference. That can make a huge impact in the amount of nutrients available to you when that comes out as a powder. So those are things you need to consider. What item are you trying to dry? What property are you trying to influence? If you're just looking to convert a spinach slurry, for example, into a powder, spray drying can do that for you. But if you're looking to test that final powder for a certain nutrient, then you might have some loss there. So there are some changes that occur during spray drying. It can be considered a more efficient way to dry something over freeze drying. But again, it has its own challenges with the temperature being a big part of it.
Okay, that's great. If you've asked additional questions and we haven't answered them yet, we will be following up via email this afternoon and responding to as many questions as possible offline. Thank you very much for your time, and we hope you have a wonderful rest of your day. Thank you.